Now, to answer a question like number 4, which compound is less acidic, I think it's helpful to be aware of the relative acidity scenarios that we talked about in class, and there's 4 of them. And this is all with regard to the anion and being able to tell which one's more stable. So it turns out that if the first thing we want to do here is, if we've got 2 acids that aren't anions, we want to turn them into H+ and the anion. So that's going to disappear, that scenario, but they'll come back in a second. So what we need to do here is remove the hydrogen from the more electronegative atom here, which is going to be the oxygen here and not the carbon. So that's going to leave us with an O- here and H+. Now we know it's H+ because we're talking about acidity here. So I'll do the same thing on this one as well. And then we'll bring up the scenarios here. We'll try to figure out which of these scenarios is going to be applicable to this situation. The first scenario is the negative charge on different atoms. As you can see here, O-, N-. Here they're both on O-, so it's not scenario 1. Scenario 2 is a halogen attached at a different distance from the negative atom. Well, if you look at this example, you see the C is on the F is on the NC, and here the F is on the middle C. That's not the case here. The halogens are on the same carbon atom. So it's not number 2. Now number 3, is there a different halogen attached at the same location? And the answer is yes. We've got Br here versus F here. Are there different numbers of halogens attached? No, we've got 2 here and we've got 2 here. So we know that it is scenario 3. Now to explain the stability difference of the anions for scenario 3, we need to do a little bit of work with our polarities. Now here's what we know. If we're going to express polarity, we know that the Br is going to have a delta minus. We know the C is going to have delta plus. Now when we set this up, the delta minus means a partial negative charge. The delta plus means a partial positive charge. We'll do the same thing down here on the fluorines. And we know that the delta minus always goes on the more electronegative of the 2 atoms. And the more electronegative one is going to be the one that's closest to fluorine, or it's going to be a halogen on the periodic table. So here we've got delta minus because it's on the Br, and then C is delta plus. And here we've got the same thing. The delta minus is on the F, and the delta plus is on the C. Now the way we explain this now, in terms of stability, has to do with what the bonds look like. Now because of the electronegativity difference, we know that in a bond between C and Br, the electrons are going to be between the C and the Br, but they're going to be a little bit closer to the bromine than the carbon. Now if we've got fluorine, we know that it's more electronegative and that the electrons will be closer to the fluorine than they are to the carbon, but even closer to the fluorine than they are to the bromine in the top case. So what that means as far as partial negative charge goes, because the electrons are closer to the fluorine, we could put a big delta minus on that, and for the bromine we can put a smaller delta minus on that. Now a big delta minus means a big delta plus on the C, and here a little delta plus on the C. So what that means is that the stability of the anion now is going to be determined by the size of this delta plus. Because the bigger the delta plus is, or the more positive it is, the better it will stabilize the negative charge on this oxygen that's nearby, which makes the anion more stable. So as you can see here, in the case with the fluorine, that's going to be a bigger delta plus, which means that's a more stable anion, which makes this one more acidic. This compound here is going to be more acidic. It means it's going to lose an H plus more easily because the anion's more stable. So over here we're looking for which one's less acidic. So the less acidic one is the one that has the less stable anion, and that's going to be this one here. So this would be your answer for this specific problem.